Hello students, now our topic is cloud chamber. So cloud chamber is an instrument used for the visual observation of the tracks of the charged particles in their passage through matter. So this is a visual observation. We are going to take the photograph of the ionized regions. Okay, this is the instrument used. The principle is visual observation of the track of the charged particle. C.T.R. Wilson was the person who first designed this, and hence this chamber is called Wilson cloud chamber. The principle: when air is mixed with a saturated water vapor, it is suddenly expanded. It is adiabatically expanded. Adiabatic means there is no interaction with the surrounding. Okay. When it is adiabatically expanded, it will result in fall of temperature and supersaturation of vapor. Okay, so there is a fall in temperature occurs. The vapor will condense in cloud of water droplets. These vapors will condense in the form of clouds of water droplets. The production of such a cloud is, however, impossible unless nuclei on which the water vapor may condense are provided. So we have to provide the condensed water vapor to settle down on some nuclei. So if the particles of dust are present in air, they will act as a condensation nuclei. If it consists of air inside the chamber, it will be settling on that dust particle. But in a dust-free air, this phenomenon of condensation and formation of cloud will not occur. C.T.R. Wilson discovered that the condensation cloud could be produced even in dust-free air, provided the air was ionized by ionizing agents such as X-rays, cathode rays, or any other nuclear radiation. So in a dust-free air, if we produce some positively or negatively charged ions using such rays, that ions can serve as a condensation or the center for condensation. This was invented by Wilson in this cloud chamber. When ionizing agent enters the chamber, immediately before or after the expansion of the piston, the ions left in its path would act as a condensation nuclei. The experiment shows that as supersaturation increases, the negative ions first serve as centers of condensation, then as the volume increases, both positive and negative ions serve as the nuclei of droplets. In short, the working principle of cloud chamber is that charged ions can serve as nuclei of condensation of water droplets in a dust-free atmosphere of air water vapor mixture under the condition of supersaturation. This is the working principle. So this is our construction. It consists of a large airtight cylindrical chamber. This is a cylindrical chamber A, with the walls and ceilings are made up of glass. Walls and cylinders sides are made up of glass, particularly plain glass plate. The chamber consists of dust-free air. Saturated with water vapor of some volatile liquid. The mixture inside the chamber can be compressed or expanded with the help of a piston. Here is a piston. You can see it tightly held. This is the original position, and we are expanding this on changing the position to this position. We are expanding the mixture. Okay, so this is the process. This is a powerful light flash which helps to ionize the materials inside this chamber. So the mixture inside the chamber can be compressed or expanded with the help of piston P. The surface of the piston is usually covered with black felt so that no light is reflected from it to enter into the camera facing the front side of the chamber. This is a camera. Here we are visually observing, or we are taking the photograph of this clouds or the water droplets condensed on the nucleus. charged ions. So we'll be studying working. To begin with, the piston piece moved suddenly down. As a result of this, the mixture undergo adiabatic expansion, due to which the temperature falls. At this reduced temperature, the mixture becomes supersaturated with the vapor and remains as such without any condensation of vapor. Now, for condensation to occur, nuclear centers are required. For this, a powerful light flash is allowed to pass through the mixture immediately before or after moving the piston. So, after moving the piston and allowing it to make it to cool into supersaturated position, a light flash is allowed to pass through the mixture. This results in ionization. The positive and negative ions act as a center of condensation. That is, the ions acts as the nuclei of droplets. A close array of fine droplets, that is a kind of linear cloud called a cloud track, will thus be formed. By using strong illumination from the side, the track appears as a white line on a dark background. This white line is the formed condensed vapor particles on the ions. So it appears as a white line on a dark background. This can be photographed by means of a camera fitted at the top. This is the working. Now what are the uses of this process? To study the behavior of individual atoms. Second is to study the specific ionization along the track of charged particle and the range of such particles. Third is the polarity of the charge and momentum of the particle can be determined by placing the chamber in a magnetic field. When we place this chamber in a magnetic field, the charged particle can follow a circular path whose radius of curvature can be found out by this equation mv square by r is equal to qvb. mv square by r is the centripetal force and qvb is the magnetic force. So, in a circular path inside a magnetic field of B value, magnetic field, Q is the charge of the particle, V is the velocity, M is the mass of the charged particle, and R is the radius of curvature of the path. So, when we equate this to V, one of the V is cancelled, we get the momentum mv is equal to qbr, and the direction, the polarity of the charge and momentum can be calculated. The direction of the radius, the direction of the movement can give you the polarity, and momentum is equal to qbr. Okay. Now what are the disadvantages? The main disadvantage of cloud chamber is that it needs a definite time to recover after expansion. Hence, it is not possible to have a continuous record of the events taking place in the chamber. This is one of the disadvantages. Second is that it cannot be used for detecting high energy particles, since the interaction of the energetic particles cannot be completely observed in the chamber. So, it cannot be used to detect high energy particles. These are the disadvantages.